Okay, hi guys. I'm Ria Bhatia. I'm a product manager in the AKS team and ACI team, so Azure Container Instances team and Azure Kubernetes Service. We've rebranded and we are calling ourselves Cloud Native Compute PMs.
Cool. Hi, my name is Janakiram, Jani. I'm a Microsoft MVP and a regional director from Hyderabad, India.
Cool, so let's get started. The first thing I want to talk about is serverless. What is this term and what are we talking about here? There's a lot of overblown terms with serverless. There's functions, right? There's logic apps, there's app services, and you're always like, okay, well there's no VM infrastructure underneath that. What I'm here to say is now we're coming up with something called serverless Kubernetes, and it starts with serverless containers. I'm sorry, they're all marketing terms, but we'll try and break it down and give you real-life examples for what's going on here. All right, yeah, cool. So ACI, Azure Container Instances. It was the first of its kind, the first of any cloud to just basically run a container in Azure. That's all you do. You can throw it an image, you can throw it compute, so the amount of cores you want, the amount of memory, and it just spins up in seconds, depending on how big your image size is. We also have some new features coming out that just came out this week. You can bring your own virtual network. It's in preview. It's only for Linux containers. So if you have really bursty workloads, you're going to want to run ACI. It's not really good if you're just running like a website, for example, but it's really good if you just have bursty workloads, input-output, data transformation. That's what it really should be used for. Also, the reason we say bursty is because it's not cost efficient to use it as a replacement for long-running services. If you decide to use this as a replacement for long-running services, you will be surprised at your bill, so don't do that. And that's why we market it as a bursty kind of compute. Yeah, next slide. Cool. So I just talked about ACI. Those are serverless containers. You don't have any VM infrastructure that you manage. And now I'm going to talk about orchestrating containers. So these are two separate things. One's just containers that come up in the cloud, and this thing is how do you orchestrate all these containers in the cloud? And this also has VMs underneath it. It's not just containers that are laying in the cloud. It's 100% upstream Kubernetes. We do automated upgrades, patching, all that fun stuff. We hold your master nodes. So what that means is we hold that Kubernetes service for you when we manage that. We give you agent nodes and we give you like the kubectl command line. That's how you interact with Kubernetes to be able to deploy and scale your applications. So if you're in a microservices kind of environment or you want to get started, just start containerizing your stuff, right? And try and deploy like one container to Kubernetes and see what happens. Now try and deploy more and see how it scales and how it puts things on different nodes. So if you're getting started, just start that way. It's a little bit of a learning curve, but it's actually not too bad. There's a lot of open source docs online where you can learn more about how to get started. We also develop in the open through ACS Engine. So if you want to see all the nuts and bolts, if you want to see even some of the features we're about to bring out in AKS, we have an engineering team that's developing in the open in a GitHub repo. So check it out, it's just ACS Engine. Probably Google search it. And next slide. Cool. So I just talked about serverless containers, right? And then I talked about, okay, now how do we orchestrate these things called containers? Now I'm saying that we can actually connect these two things together. So with ACI, you just get containers in the cloud. With AKS, you get the management of Kubernetes, and put those together, you get basically no VM management, right? Because we've taken away your master nodes, we're managing that for you. And we're giving you containers that scale in the cloud without any VMs underneath. We have this thing called virtual nodes, which we just released in private preview this week too. And basically it shows up as a virtual node. There's no physical VM behind it. It's actually just an interface, just a string that shows up when you say kubectl get nodes. And when you deploy to that node, it spins out into ACI. So you can spin out Windows containers, you can spin out Linux containers, and some cool things about this is we have networking enabled for the Linux containers. So you can put it in your own virtual network, and we also have service discovery. So it's gonna feel like a Kubernetes cluster that you're used to. And that's actually pretty awesome because no one else has this. No one else has this no VM management sort of experience and this easy scaling experience. So I'm going to give you an example for what it's like today to scale in Kubernetes if you're just on a normal Kubernetes cluster. You use the horizontal pod autoscaler, and you'll also use the autoscaler for nodes in tandem. First, you'll try and schedule out pods, and then when you're over capacity in your cluster, basically Kubernetes will be like, okay, now I need to go and scale out a node. It'll go scale out a node, and then it will scale out the pods. This process in Azure can take a couple minutes. And sometimes you need burst capacity. So what people end up doing is over-provisioning their clusters. That costs you money. It wastes your time because you have to manage some parts of that auto-scaling. But with this, you can just scale on demand. So if you go back and watch Monday, Corey Sanders' session with Locky, if you go to like 35 minutes, you'll see this awesome demo of burst auto-scaling with live metrics, which is something really special. We're actually using live metrics in real time to scale, which is pretty awesome. So the virtual node architecture here, we have the Kubernetes control plane, we have these 4 VMs. This is what AKS looks like today, right? And a lot of people will probably put like a couple pods, but you don't want to put too many or else you'll be out of capacity. So you can use the virtual node to just burst out when you need it. And this is the architecture. So that virtual node kind of looks like a node, but it really is backed by Azure Container Instances. So if you wanted to, you could go in a different region. It's really flexible the way that you could use virtual nodes. Cool, so I'm gonna go out and I'm actually gonna go into Azure really quick. Cool, so I'm gonna show you how today you can actually use the private preview experience. You're gonna go ahead and say create resource, and then you're gonna say Kubernetes, create, and then you see this virtual nodes experience right here? That's what we're talking about. It's that easy to get this node in your cluster. Just hit enabled, hit review and create. You don't have to do the networking stuff. We've defaulted, and that's it. Cool.
Great.
Yeah, so I think my stuff is done. I'm going to hand it off.
All right. Thanks, Ria. So what actually powers Virtual Node behind the scenes is an open source project called Virtual Kubelet. And Virtual Kubelet integrates with an existing Kubernetes cluster. It could be any cluster. It need not be just AKS. It could be Minikube. It could be GKE. Any other valid Kubernetes cluster can be integrated with a third-party resource scheduler through this project called Virtual Kubelet. So Virtual Kubelet is more like a bridge, which is going to connect one end of the spectrum to a Kubernetes control plane and the other end of the spectrum to a third-party resource scheduler. For example, the virtual node implementation that Ria has shown, one end of the spectrum is ACI, serverless containers. The other end of the spectrum is AKS, a Kubernetes control plane. And what Virtual Kubelet does is it brings a third-party scheduler as a virtual node, as a literal node into the Kubernetes context, into the Kubernetes realm. So when you actually do a kubectl get nodes, a third-party resource scheduler shows up as one of the nodes. And the magic behind that is enabled through this project called Virtual Kubelet. So today, Virtual Kubelet supports a handful of schedulers. Of course, AKS is one of them and ACI, but it's not just Microsoft's own implementations. Amazon has integrated Fargate, their equivalent of ACI, the serverless containers. And one of the very exciting implementations of Virtual Kubelet is integration with IoT Edge. And there is a lot of synergy between these two use cases. Kubernetes is primarily designed to handle deployments at scale. So it can deal from a couple of containers to tens of thousands of containers very seamlessly. That's one side of the story. There is another side of the story where we are dealing with a lot of scale with the explosion of devices. Today, when you actually look at industrial IoT, there are millions of devices and sensors that are getting onboarded. So there is a kind of an analogy that is evolving between Kubernetes and industrial IoT. So here we have containers that are exploding into a few millions of containers, web scale computing and so on. On the IoT side, on the industrial IoT side, there is an explosion of sensors, actuators, and devices. So can we use Kubernetes to manage this explosion of devices using familiar tools and familiar terminology? So that's what is enabled by the integration of Virtual Kubelet with IoT Edge. So I want to show you a quick demo. So here I have two things. What you actually see here is a Raspberry Pi, and this is my edge computing device. So this edge computing device is going to interface with one of the actuators, and this is a smart bulb. If you are familiar, this is a Philips Hue Go smart bulb. Now, this could be a smart building scenario where an edge device is deployed in every floor of the smart building, right? And I want to basically control the bulbs via the edge device and using Kubernetes. So how do I actually get to that? So now let me show you the interface. So I have two terminal windows. The terminal window here is actually a Raspberry Pi. So I have SSH'd into the Raspberry Pi, and I have already configured Azure IoT Edge. So it's currently running a couple of containers as modules. The cool thing about Azure IoT Edge is it's almost like a Kubernetes pod. For example, this Raspberry Pi can be logically visualized as a pod. And just like a pod, this edge device is running multiple containers. So it makes a lot of sense to use Kubernetes to orchestrate the pod and the containers inside the pod from a central control plane. So we already have two mandatory system containers deployed on my edge device. And now what I'm going to do is to use kubectl to basically orchestrate my edge deployment. So before that, let me do a kubectl get nodes. So this is Minikube. This has nothing to do with AKS or Microsoft's own implementation. I'm using Minikube on my local machine. And what you see here is 2-node cluster, but interestingly, building 1 is actually not a physical node or a VM. It is an IoT hub connected to my edge device running in a smart building. So if I have multiple IoT hubs, using Virtual Kubelet, I can register them with my Kubernetes cluster, and when I do kubectl get nodes, I'll have building 2, building 3, and so on. So every building is going to be like a node, and every edge device is almost like a pod. And you can deploy multiple pods using standard kubectl taxonomy. So let's go ahead and do that. I want to show you a very simple YAML definition, right? And if you are familiar with Kubernetes, you will instantly relate to this because it's not a new markup, or it's not a very different way of declaring your artifact. It is essentially a Kubernetes deployment. All I'm actually doing here is using some annotations which are very generic, and I'm saying that target this deployment on any edge device where the tag type is bulb. It's almost like node affinity in Kubernetes. When you're deploying high throughput I/O databases, you would want to deploy them on a VM backed by an SSD. So you actually put that here, right? So you'll say deploy this pod on a node that has an SSD backend, and the scheduler will place it on that. So similarly, I'm saying run this module, run this pod on any edge device that is managing a bulb. So I mentioned that definition, and this definition is actually a part of my Kubernetes, Azure IoT Hub device twin. So if you're not familiar with IoT, don't bother, but what I mean to say is when I'm actually deploying my edge devices, I will put some tags which are very specific to IoT Hub, and in this case I'm saying the device ID is Pi1, type it is managing is bulb. Essentially I'm using the same annotation back in my YAML. All right, so then I give my module name, which is bulb v1. So now with this YAML in place, and I also have a config map to feed in some configuration details to the containers running inside the pod. So what I'm going to do now is use my standard mechanism of deploying a pod. So kubectl apply bulb.yaml, and now very soon we'll actually notice that we'll have a deployment which is called bulb, and we are also going to see pods that are getting created. And if you notice the lower window, there is no module called bulb running. In just about a minute, that will show up. And as soon as that module comes up, my Raspberry Pi will glow a bunch of LEDs in blue, and the smart bulb will also turn blue. And that's an indication that the module is now pushed to the target edge device. So the edge hub has failed, which means it is restarting to pull the new module. And in just about a minute, we should actually see V1 getting deployed. To make it more meaningful and to make more sense for the Kubernetes audience, I'm using a blue-green deployment. So my V1 is turning up the bulb into blue, and there we go. So this is V1, and as soon as that module is pushed, both my Raspberry Pi and the bulb actually glow blue, right? And this is V1. Now I can target a bunch of bulbs with the same taxonomy of giving a tag. Now, what I'm going to do is to update the image. Again, I have no knowledge of IoT. I'm a Kubernetes DevOps engineer. All I'm going to do is, I don't like this color, or I want to upgrade the image. I'm going to run this standard command of kubectl set image, where I'm upgrading my image from kubectl, and this will negotiate with the IoT hub and automatically pushes a new image to my edge device. And because this is a blue-green deployment, V2 translates to green color, and in, again, about a minute or so, we'll notice both the Raspberry Pi and the smart bulb becoming green. So while that is happening, let me show you. Okay, now the bulbs went off because the module is getting refreshed. In real-world use case, we can actually continue to run them till the deployment is successful. But to make it visually appealing and indicative, I'm actually switching off the bulb. So any moment now, they'll turn green, indicating that now the new version of the module is deployed on the edge device. So once it comes up, I'll switch to the portal and show you what it actually translates into the IoT edge deployment. So there we go. Now that's it. So now the bulb has turned green, and this is V2. So when I actually switch to my IoT edge deployments and do a refresh, this actually shows two deployments that are pushed via kubectl, right? So this is the most recent one, and this is the most recent one. It is targeting one bulb, and the status has changed to applied. But because I'm using Kubernetes way of doing things, I can actually do a kubectl rollout history, and it tells me everything that I have done so far. And like PaaS operations, I can do a rollback. For example, I don't like this, or there is a mistake in my module, so I can actually undo the deployment. And when I undo the deployment, we are rolling back from V2 to V1, and the whole process repeats. Very soon, V2 gets knocked off, V1 comes back, and the bulbs go back to blue. And you can do this at scale. Obviously, I cannot bring dozens of devices, but I can technically target. There we go. Now it comes back into blue very soon. And this is actually a blue-green deployment of IoT edge devices managed via Kubernetes. The most familiar, the most common workflow of managing canaries and blue-green deployments is now brought to IoT edge deployments at scale. And the magic behind this is Virtual Kubelet, which is registering an IoT hub as a node and giving you the power of kubectl to manage the entire operations and workflow. So as soon as this becomes blue, my demo is done. That's it. Thank you.
Yeah, go ahead. Cool. You can take this one. Yeah.
Yeah. So as I mentioned, Virtual Kubelet is an open source project. It is actually written in TypeScript. You can go to GitHub. You can clone the repo.
Go now.
Go, okay.
Yeah.
So I'm sorry. The very first implementation was written in TypeScript. Now it's upgraded to Go. So you can actually clone the repo, take a look at it. And this is becoming an industry initiative, because the ability of treating Kubernetes as a universal scheduler is getting a lot of attention, and there is an industry acceptance. So it is not just Microsoft, but as I mentioned, you have seen AWS integrating that with Fargate, but other providers like Alibaba, Huawei, VMware, and most of the other Kubernetes players in the ecosystem are contributing to the Virtual Kubelet project, and very soon we'll see a lot of other integrations. And that actually underscores the whole evolution of Kubernetes as a universal scheduler. It's not just to do with containers and pods. You can orchestrate a variety of resources, including IoT edge modules and IoT devices, and that is an indication of the growth of Kubernetes and the power it is delivering. So cool. That concludes the session.
Yeah, thank you. I'm just going to show you.
Oh, sorry.
One last thing. If you want to sign up for the private preview so you can easily get this virtual nodes feature in AKS, sign up here. If you want to get started with IoT Edge or any other providers that Virtual Kubelet has, go to the GitHub page, Virtual Kubelet. And we also have a bunch of samples on Azure samples to autoscale, and then Virtual Kubelet also has a bunch of examples in it too. So yeah, thank you.